Hello guys, so in this video we will be looking at how to solve this question. So it's a very easy question, but it takes time to solve. So this is what we will be solving in this video. So the question says the above mixture must be separated by distillation so that 95% of C3 charged is recovered in the distillate and 90% of C4 charged is recovered in the bottoms. So this C3 would be our light key component and C4 would be our heavy key component. Before solving, I always advise students to first draw the column, that's the distillation column. That way it would help visualize the problem, making it easier to tackle. So we have a feed. Now all of these components are going into the feed. Okay, these are charged into the system. That's the feed over here. And remember the question said the feed is 100 kilogram mole, so 100 kilogram mole. Now what comes out at the bottom is the W. Then we have the condenser here. We have the reflux and the distillate, D. Okay. Now the above mixture must be separated by distillation so that 95% of C3 charge is recovered in the distillate and 90% of C4 charge is recovered in the bottoms. So question 1, estimate the distribution of the other components and hence complete the above table, assuming that the column is operated at total reflux. So what this question 1 is saying is that we should estimate the distribution, that's this column and this column. So what we would be doing would be how to fill this column and this column. Then question 2 says how many minimum number of stages is required. How many minimum number of stages should be required for this separation. So we look for the minimum number of stages, which is Nm. We'd use Fensk Equation for that. Then the last says we should determine the overall composition, which is this and this. So we would solve all of them together. Okay, 1 to 3, we would solve all of them together. So how do we proceed? First, let me fill this column because I think it will be very easy to fill since we've identified our heavy key component as C4 and our light key component as C3. And let me just fill this column first before we begin anything. And we know that relative volatility of a component with respect to the heavy key is the K value of that component over the K value of the heavy key. So this has been established in the lecture notes. Okay, so to fill this table would simply be K, this is the heavy key C4, to simply be 4.9 divided by 0.85, you will get 5.8. Then that's Ki over KHK. Now you divide 1.9 divided by 0.85. 1.9 divided by 0.85. Then 2.24. 0.85 divided by 0.85 is 1. 0.35 divided by 0.85. That's 0.41. Now 0.17 divided by 0.85, that's 0.2. Then we have 0.08 divided by 0.85, now 0.094. So this is what we have. So it's very easy to fill this. Remember to write it out. So that's alpha C2HK is equal to Kc2 over Khk, where Kc2 is 4.9. That's 4.9 over 0.85. So alpha C2HK becomes 5.8. That's how you got the first one. Then the second one, alpha C3HK is 1.9 over 0. That's 1.9 over 0.85. So alpha C3HK becomes 2.24. So that's how we got the second one. So you just write it in this format for all of them, because when the lecturer is grading your work, he would grade based on the steps and not just the table. So ensure you write out all the steps. Okay, so moving on. So you do that for alpha C4HK, which is equal to 1. Then we have alpha C5HK, which is equal to 0.41. Alpha C6HK, which is equal to 0.2. Alpha C7HK, which is equal to 0.094. So you get your full marks in electrolyte marking. Okay, so we're done with this first column. Now let's look at how we can fill these. Now from the question, it says that 95% of C3 charge. So let's fill C3. So we'll just fill them sequentially, fill them like this, like this, like this. So let's find component balance for C3. Let me shape this. Okay, so let us look at how we can do it. Now the question said that 95% of C3 charged, meaning C3 in the feed, that's C3 in feed, is recovered in the distillate. What this means is simply 95%, 95 over 100 of simply means times C3 in the feed. So you look at the feed. What is C3 in the feed? Is 20. 20 is equal to C3 in the distillate. That's dxC3 in the distillate, because this is the total distillate multiplied by the fraction. You get the total value of C3 in the distillate. So this becomes, so if we make this subject of the formula, dxC3d becomes 0.95 times 20, becomes 19. So this becomes 19. So you see how we're filling our table one after the other. Now also component balance for C3. We know that C3 in the feed, which is C3 in the feed, which is Fx C3 in the feed, is equal to C3 in the distillate, which we just found, xC3 in the distillate plus C3 in the waste. Now we're looking for C3 in the waste, which is this one. So this one is FC3 in the feed is 20. So we have 20 is equal to, we just found this one to be 19 plus. So C3 in the waste becomes 20 minus 19 is 1. So we found this one, which is 1. Now to find xdi, if dxdi is 19, okay, if we can find the value of d, they would be able to find xdi. So how can we find the value of d? We would have established this initially. So let us establish a value for d. Okay, how do we do this now? Let me just draw a separate column. So this should be one of the first things you would establish. Let me draw a separate column. Now if you look at C2, okay, let me just continue from here. Let me continue from here. Okay, since this is a different component, let me just do it from here. Now if you look at C2, let me bring the question closer. You would see that, okay, let me write general mass balance. Okay, we could still get it from C3. I'm trying to look for the easiest way we could do this. I'm trying to look for the easiest way we could do this. Okay, good. There is no need to even have a general mass balance. Now from C2, let's see if this is being captured. Okay, from C2, dx, so dx C2 in a distillate is equal to what? 4.99945. Okay, now x of C2 with the distillate is equal to what? From this column we have 0.185. so if d times this gives this and only xc2 is this, so to find d you simply divide this by this, so it means that d becomes dxc2 in the distillate divided by xc2 in the distillate. Okay, so which would be 4.99945 divided by 0.185. So d becomes, we use our calculator, 4.99945 divided by 0.185. So we have 27.02 kilogram mole. Okay, now if your feed is 100 mole, it means that W becomes 100 minus this, because feed is equal to D plus W. So W becomes feed minus distillate. So that is 100 minus distillate, that's 72.98 kilogram. So that is the bottoms W. So we would need this now to calculate XDI. So if D is equal to 27.02 and dxc3 in the distillate is 19, so we can find xc3, the fraction of xc3 in the distillate. So the fraction xc3 in the distillate becomes, it simply becomes dxc3 in the distillate divided by D, so that when D cancels D, you'll be left with just the fraction. Okay, so xc3 in the distillate becomes 19 over 27.02. 19 divided by 27.02, that's 0.703. So 0.703. So xc3 in the distillate is 0.703. So we found another. So this is 0.703. Okay, so now to find xwi is the same thing, that's xc3w. So to find this, you know that the w is 72.98, we calculated that already here, and wxc3w from our table is 1, That means that the fraction xc3w becomes 1 over 72.98. Just the same way we solve this, so that xc3w becomes 1 over 72.98. That's 0.0137. So we found another 0.0137. So you see how we've filled this row very easily. Now the next thing we want to do is to fill these orders. We do not have any detail. We do not know the distribution in the distillate for C5, C6 and C7. Neither do we know the distribution at the bottoms. So we need two equations, but let's just proceed. Now components, so we are done with C3 now. Component balance for C5. So we want to fill C5, C6 and C7 for C5 now. Now, you know from component balance, x of C5 times the feed is equal to x of C5 in the feed times the feed is equal to x of C5 in the distillate, the fraction of C5 in the distillate times the distillate, plus the fraction of C5 at the bottoms times the bottoms. Okay, now what is everything here? The total amount of C5 in the feed is 20. So we have it as 20 equal to total amount of C5 in the distillate. Okay, we do not know it, but we know the value of the distillate. So let's write this. So x C5 in the distillate times, what is the distillate? 27.02 plus x C5w, we do not know it, but we know the waste as 72.98. So we have an equation. 20 is equal to 27.02 x C5 in the distillate plus 72.98 x C5 the waste. So this is equation 1. So we need a second equation. We need a second equation to be able to solve it, because we have two unknowns in one equation. So we have to come up with a second equation. So how do we do this? There's an equation we call Fensk Equation, which goes like this. S of a component, let's say A, is equal to the relative volatility of A with respect to a heavier component times the minimum number of stages, S of the heavier component. So S of a lighter component is equal to the relative volatility of the lighter component to a heavy component, which is the power of the minimum number of stages times S of SB. Now let me define these terms. SA, okay, XA simply, it's a term which simply means okay, SE, that's S X of E in the distillate. So it's just a split. The split ratio shows the split, how it splits, how the component splits from the feed to the distillate and the waste. Okay, so it's the ratio of the distillate, fraction in distillate to the fraction at the bottoms. So XAD over XAW. So that gives the split. Y S of B is equal to XBD over XBW. Okay, that's how you get this split. But remember, like I said, this time around our heavy key would take the place of SB. So wherever we see B, we put a heavy key. Okay, so take note of that. So this becomes so let's make NM the subject of the formula. like I said, this is Fensk equation. Fensk equation. Now, if we are to make NM the subject, if we take ln of both sides, so ln SA would be NM could come down. Okay, let me just write it fully for those who may not understand. So if we are to open the ln, this becomes NM ln AB plus ln SB. Okay, if we make NM the subject of the formula, NM becomes ln SA minus ln SB over ln AB. If we are to further simplify this becomes ln SA over SB over ln relative volatility of A with respect to B. So this is the formula we'll be working with. Let me put the values of SA. So NM becomes ln. What's SA? We defined it. So let me just use I. That will be a component. So this is X of I in the distillate over X of I at the bottoms. Now divide by, so let me divide by SB. Remember that SB, like I said, is the heavy key. So that is S heavy key becomes X of heavy key in the distillate over X of heavy key at the weight. That is the split. So if we are dividing this, and we want to use product here as time. So X of heavy key W over X of heavy key in the distillate. This is what we have over relative volatility of ln I heavy key. Okay, so we just replace B with heavy key. So NM becomes ln. What is X of the I we are working with now? Okay, we could, in fact, as a matter of fact, at this point, since we are looking for the minimum reflux, we are working with light key. Yes, light key and heavy key. Please take note of that. Light key and heavy key. So this our I should be our light key. Yes, exactly. So XID becomes, what's the light key? Light key in the distillate. So you could change this to LKD, LKW. So what's light key in the distillate? X of light key in the distillate, that's 0.2. This is the actual amount, but the fraction is everything divided by 100 because the feed is 100, so it's 0.2. At the bottoms, the fraction of at the bottoms is 0.0137. Okay, multiplied by heavy key at the bottoms is 0.37. Heavy key at the, sorry, remember, I'm mixing this up now. It's the distillate we're looking at, not the feed. Like I said, X of light key in the distillate, which is 0.703. Okay, these minor mistakes called cost one marks. So let's pay attention to these minor details. X of light key in the distillate, which is this one, 0.703. Light key at the bottoms is this. Heavy key at the bottoms is this. Heavy key at the distillate is 111. The relative volatility light key to heavy key is 2.24. So if we are to do this, we have ln 0.703 0.703 0.0137 times 0.37 to 0.111 lane 2.24. So our NM is 6.38. So this is our NM. Okay, our minimum reflux, this is it here. So now we can go back to this equation, our Fensk equation for S3. So first, from Fensk equation, SC5 is equal to alpha C5 NM C5HK SHK. Okay, so that SC5 becomes, what is alpha C5? Instead of the state of C5 with respect to HK, that's 0.41. What is NM? 6.38. What is SHK? This is SH. SHK is heavy component in the distillate, which is 0.11, over heavy component at the bottom, which is 0.37. Okay, so SC, can we see what I'm doing? So SC5 becomes, that's 0.41 raised to the power of 6.38 times 0.111 divided by 0.37. That's 0.001. You can now remember that SC5 is a split. So the split of C5 now becomes, this is equal to the split. SC5 is a split. That's X of C5 in the distillate over XC5 at the bottoms. So if we cross multiply, XC5 at the distillate minus 0.001 XC5 at the waste. This gives us our equation 2. So we solve equation 1 and 2 simultaneously. Make sure this video is working. Okay, so you solve equation 1 and 2 simultaneously. Now if I solve them simultaneously, I just want to use my calculator. 27.02, 72.98, 21 minus 0.001, so equal to 0, remember. So our X of C5 in the distillate becomes 0.00027, and X of C5 at the bottoms becomes 0.274. So that's how we find this. C5 in the distillate 0.00027, 0.27. So you see, these results even make sense in that the value of XC5, C5 is heavier than heavy K, so the value in the distillate begins to drop drastically, while the value drops drastically, while the value of C5 in the waste is still gaining weight. So that's how we work. Then the next thing is to find the D and W. So remember, to find the D, let me bring another paper. So we just continue. So to find the D, okay, just be sure everything is set. So to find the D, simply, we know the value for D as 27.02. and we know xdi and xwi. So dxc5 in the distillate becomes x of c5 in the distillate times d. What is x of c5 in the distillate? That's what we found as 0.00027 times. What's the distillate? 27.02. So if you times this, dx of c5 in the distillate becomes 0.0072954. So you go to your table, 0.0073. Okay, so then to find the value of xc5w, simply the same thing, xc5w times w. So xc5w, we just found it to be 0.274 and w is 72.98. So wxc5w becomes 0.274 times 72.98. That's 19.997. So you fill it in your table, 19.997. So we have two columns left. So component balance for C6. So xc6 in the feed times the feed is equal to xc6 in the distillate times distillate plus xc6 at the bottoms times the bottoms. C6 in the feed is 20. Everything here is 20. Or you could say, if you want to pick them singly, xc6 in the feed is 20 by 100, which is 0.2. The feed is 100, so you see that it still gives you 20. X in the distillate, we do not know it. The distillate is 27.02. We do not know this, but the waste is 72.98. So we have 20 is equal to 27.02 xc6d plus 72.98 xc6w. So this is equation 1. So to find our equation 2, we do not need to find nm from the scratch anymore because we already know the value for nm. So what we do is simple. From this stage, SC6 becomes, what is the relative volatility of C6HK and relative volatility of split of HK. So split of C6 becomes, what's the relative volatility of C6 HK? 0.2. What is NM? 6.38. SHK is 0.111 divided by 0.37. Okay, so this becomes 0.2 raised to the power of 6.38 times 0.111, 0.37. So xc6 becomes 0.0000104. Remember that split simply means C6 in the distillate over a fraction of C6 at the bottoms. That's the meaning of this, and it's equal to 0.0000104. So if we cross multiply and bring everything to one side, xc6 xc6 in the distillate minus 0.00000104 xc6 at the bottom is equal to 0. This is equation 2. Solving both of them simultaneously, we have we have 27.02, 72.98, 20, and then we have 1 minus 0.0000104. So xc6d becomes 0.00003, and xc6 waste becomes 0.274. So these are our answers. So 0.00003 and 0.274. So like we did before, to get the xc6d, simply the value for d, simply d times xc6d. D is 27.02. This is what we just found. So the xc6d becomes 27.02 times 0.1234. So it becomes 0.00008, while wxc6w becomes w times xc6w. So that's 72.98 times 0.24. So wxc6w becomes 17.5152. Okay. So this is 0.00008. This is 17.5152. So I would leave this last one as assignment for you. So try your hands. Let me see if I will see the answer for that. So just try your hands. I think the answer here is 0.00001234561. That's 1 times 10 to the power of minus 7. So this is 1 times 10 to the power of minus 7. The answer here is 5. Here is 0.0685, and here is 0.05. So your assignment, just try your hands on it and get those answers. So thank you. I still remain Fensk Eeshiemogie, and this is Chem Study Tutorials.